Let's calculate the pH of each of these solutions at 25 degrees C, meaning that the Kw is 1 times 10 to the minus 14, and indicate whether the solution is acidic or basic. For the first solution, we have a hydronium ion concentration of 1.8 times 10 to the minus 4. So remember, the pH is the negative log of the H3O plus concentration, the hydronium ion concentration. So the pH is equal to negative log of 1.8 times 10 to the minus 4. So that's negative. If you put log of 1.8 times 10 to the minus 4 in your calculator, you get negative 3.74. So negative times negative is positive, so we get 3.74, which is less than 7, so the pH of this solution is acidic. If you are having trouble remembering those rules, just go back to your pH chart that we had here. So if the pH is less than 7, the solution is acidic. Next we'll work B. Okay, B says that our hydroxide ion concentration is 1.3 times 10 to the minus 2. So remember that we need the H3O plus concentration to calculate pH directly. Now you could calculate the pOH, which is the negative log of the hydroxide ion concentration, and just subtract that from 14 to get your pH, which probably would be the easier way to do it. But they want you to calculate the H3O plus concentration and use that to find the pH. So how do we do that? We know that our identity says the H3O plus times the OH minus is equal to the Kw, which is equal to 1 times 10 to the minus 14, okay? And that means that, okay, we're going to plug in our hydroxide ion concentration, and we can just go ahead and solve for hydronium ion concentration here, is equal to 1 times 10 to the minus 14 divided by 1.3 times 10 to the minus 2, and that gives us 7.7 times 10 to the minus 13. So now we have the hydronium ion concentration. And remember, the pH is the negative log of the H3O plus concentration, so we can just plug that in. The pH is the negative log of 7.7 times 10 to the minus 13 for this solution. That's negative 12.11. So our pH is 12.11. So this is basic. This is a basic solution. Now we'll work for practice 17.3. Calculate the pH of each solution and indicate whether the solution is acidic or basic. So for A, we have 9.5 times 10 to the minus 9 as our H3O plus concentration, so we don't need to calculate the H3O plus concentration. So the pH is equal to the negative log of the H3O plus concentration, which is equal to the negative log of 9.5 times 10 to the minus 9, okay, which is equal to 8.02. So that's our pH. So that's larger than 7. So that is a basic solution. So next we'll work problem B, which gives us the hydroxide ion concentration as 7.1 times 10 to the minus 3. So we need our hydronium ion concentration to calculate the pH, and the hydronium ion concentration times the hydroxide ion concentration is 1 times 10 to the minus 14, that's the Kw. So if the hydronium ion concentration is equal to then the Kw over the hydroxide ion concentration. And so that's equal to 1 times 10 to the minus 14 divided by 7.1 times 10 to the minus 3. And if you don't remember how to solve for H3O plus here, just review some of the previous videos in this playlist. And that gives us 1.4 times 10 to the minus 12. Okay, so 1.4 times 10 to the minus 12 is our H3O plus concentration, so the pH therefore is equal to the negative log of the H3O plus concentration, which is equal to the negative log of 1.4 times 10 to the minus 12, which is equal to 11.85. So this is also a basic solution.